day 2 of my little recordings. So I looked over some of your guys' results from your simple versus compound interest worksheets, and you seem to get the simple interest part down right because that's the easier one. Compound interest, some of you guys either just didn't do it yet or you had some trouble with it. As of now, though, you've spent the first 20 minutes today completing it, so it should be finished. So I'm going to go over it on here, and I'll try my best so you could follow along to see how to do it. Okay, so we'll start with the top of the simple interest table 2, because table 1 is already done. It says David receives $500 from his parents on January 1st and deposits it into a 3% simple interest bearing account. Fill in table 2 with the correct amount of money he should have at the end of each year. So he is just making a one-time $500 deposit into this account. So you get it, maybe for a birthday or something, you get your $500, you just put it into a savings account. And it's going to grow at 3%, which remember is actually a lot because usually savings accounts are about 1%. And you're just putting it there and you're not touching it. Some of you guys put here based on 100, but you got to make sure it's $500 at 3%. So what you're going to do first is you need to figure out how much is he going to have at the end of each year. So you would do $500 times multiplied by 0.03. So every year he is going to get $15 free of charge from the bank. That's called interest. And he's not putting any more money in. So remember, this first $500 that he puts in is called the principal. And he's not putting any more principal in, just the first $500. And it's going to go up by $15 each year. So you would just do 500 plus the new $15 he has. So at the end of year 1, he's going to have $515. Okay? And then at the end of year 2, he adds another $15 to that. So he'll have $530. Alright? Then the next year, he's going to get another $15. So now he'll have $540. So you see how this just keeps going up by $15 because he just put $500 in. He's not touching it. Okay? And it's going to go up by $15 every time. No problem. The bank's using that money, so they're going to keep giving him $15. Okay? Is that a lot of money? No, but it's free money. Why put this money under your mattress or in your wallet when you could just put it in a bank account and get it easily and have it go up by a certain amount of money? So with this practice one over here, we did $100 at 5% interest. This one we did $500 at 3% interest. So simple interest is very easy. You only get interest on the principal you put in. Alright, now let's get to the more difficult one, the compound interest. So you can see I showed you my math here in the orange for the first one. So I'm going to show you how easy it is to do for table 4. It says the same thing as before. David receives $500 from his parents on January 1st and deposits it into a 3% annual compounded interest-bearing account. Fill in table 4 with the correct amount of money he should have at the end of the year. So once again, at the end of year 1, you're just going to do, same as before, 500 times 0.03, alright, and he just made $15, that's it. Okay, so after year 1, he's going to have $515. But now he's going to put in an extra 15. So now at the end of year 2, though, you're not going to give him just the $15 because you're not taking the interest only on the 500. Now you're going to calculate the 3% interest on the whole 515. Okay? So what we're going to do is we're going to do 515, all right, times 0.03, 1545. So now after year 1, he is going to make 1545 in interest. So I'm just going to add that to the original 515. So year 2, he made 1545 in interest. Remember year 1 he only made 15. Year 2 he now made 1545 because we're taking the 3% on the 515 instead of just the 500. So we're going to add the 1545 to the 515. Now for year 2 he has 530 and 45 cents. 530 and 45 cents. So now we're going to keep this still up here. We're going to take 3% on this. So we're going to multiply this by 0.03. So now after in year 3, he made $15.9135 or $91. So we're going to add that to the previous number here. So you just keep multiplying it by 0.03 and then adding it to the previous number. So add it to 530.45. So for this one, we always round to 2 decimal places. So on this one now, he's made 546 and 36 cents. All right, so we keep that up there. What do we do with this part? We multiply by 0.03. So in year 4, remember, at year 1 he was only making $15 interest. Year 4 now he's making $16.39 in interest. That's pretty good. So what do we do with this number? We just add it to the previous one. So plus 546.36. So our total for year 4 is 562.75. Alright, got it? So now what do we do with this number? Well, we're going to see how much interest we earned off that, so we multiply it by 0.03. So that's how much interest. What do we do with this? We add it to the 562.75. And that equals 579.63. Alright, so at the end of year 5, we now have $579.63. Remember, we just put in $500, but because it's compounded annually, by the end we made almost $80. So $579.63. Now let's look at how much we made for simple interest. Simple interest, same exact equation, we only made $575. With compounded, we made $579.63. Yeah, it's only about $4 or $5 more, but still, why would you want $4 or $5 less? And if you put in a lot more than $500, because people put in $500 every month, it's going to get a lot more. So compounded is good. Alright, make sure you have those answers. And if you have any questions on that, please write it in the blog if you want me to go over more or whatnot. Or you could always rewind this video and watch it again. Alright, let's do the more difficult one. This one goes on for a long time. Once again, you're practicing compound interest. I've even put the answer here for you. Some of you guys weren't even close. You have to read the equation first. I even told you what you're starting with here. It says Sarah receives $9,000 from family for her high school graduation. Right? That'd be nice. You guys are all going to graduate high school in the next few years. If you got $9,000, that'd be pretty sweet. But even $900 would be nice. On January 1st, she deposits it into a 10-year CD. We're going to talk about what that is later, but it's just another type of savings vehicle. With an average annual rate of return at 6% annually compounded interest. Okay. How much money will Stephen have at the end of the 10-year CD? So over here, how much will he have? So once again, we start off with just normal 9,000 times 0.06. So let's clear this. We have 9,000 times 0.06. Wow. By just putting in 9,000 in a bank account, by the end of the year, they gave him an extra $540 for nothing. So we'll add that to the original 9,000 amount. So at the end of year 1, he has $9,540. That was nice. Just, a lot of people are going to have $9,000 in life. They put it in a CD. Now it's already at $954. Alright, so now we're going to take this number, because it's compounded, so we're going to get interest on this whole amount, not just the 9,000, on the whole amount we're going to get it. So we'll multiply this by 0.06. And then, so this is the interest we're going to earn. We're going to have to add that to what we have here to see what our new amount is. Add it, 9,540. Wow, now we have $10,112.40. Alright. Now what do we do with this number? Multiply by 0.06. Take that number, add it to the one before it. And now we have $10,719.14. Okay, because this is not quite a 5 yet, so we can't round up yet. So what do we do with this? Multiply by 0.06. And then add it to the 10,719. And now we have 11,362 and 29 cents, because we're going to round up here, because that 8 bumps that one up to 29 cents. Alright. Then here, we're going to multiply by 0.06 again. Remember, it's just you multiply by the interest rate and then add the previous number. Now we add the previous number. $12,044.03. $12,044.03. Just make sure that's right. $12,044.03. Very good. Multiply that by 0.06. Add 12,044.03. We have 12,766. 12,766.67. Alright, take that number, multiply by 0.06, add the amount before that. We now have 13,532 and 67 cents. Okay, we're getting closer to our final answer. We multiply that by 0.06. Add that, 13,532.67. We're at 14,344. And 63 cents. Multiply that by 0.06. Add that to 14,344.63. We have 15,205 and 31 cents. We're going to multiply that by 0.06. We're going to add that to the 15,205.31, and our total is, ding, 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 perfect, $16,117.63. Wow, fun. I hope you guys understood that. Once again, all you're doing is math. You're taking the number, you're multiplying it by 0.06, and then you're adding it to the principal. So then for the next one, you're taking that new number, multiplying by 0.06, adding it to the previous principal. And keep going and going and going, and that's how much money. So if you just put $9,000, okay, in a 6% interest CD, and just kept it there, didn't even think about it. You got $9,000, throw it in there. You don't need that $9,000 for 10 years. All of a sudden, 10 years later, you almost doubled your money, right? So it's over 16 grand. Very cool. That's what interest is good. All right. Once again, if you have any questions on this, put it in the blog. Then you guys did a rule of 72 problems. This shouldn't be hard. All you do is you take 72 every time. Just take 72 and divide it by whatever they give you. If they give you the interest, you divide it by the interest. Okay? If they give you the years, you divide it by the years. If they give you money, Ignore the money. The money is always doubled. So here, number 2. If Frank invests $8,000 at a 4% interest, how many years would it take for him to have 16,000? Okay, so he goes from 8,000 to 16,000. What is that doing? That's doubling his money. So ignore that. All you would do, 72 divided by 4. That's it. 72 divided by 4. So the answer is, it says how many years would it take? 18 years. That's it. All right. So if they give you the interest amount, all you do is 72 divided by that amount. That's it. Some of the problems, though, won't give you the interest. It's going to ask you for the interest. So if it asks you for the interest, then they're going to give you the years instead. So all you do is take 72 divided by that number. So Andre invests $40,000 and he wants to know what interest rate he'll need in order to double that amount in 20 years. Okay, they gave you the years. Boom. 72 divided by 20 equals 3.6. So he needs a 3.6 interest rate percentage to double his money. So if he really wants to double his money in 20 years, which is a long time, he needs to find something with 3.6% interest. So number 5 is you have to figure out which one it is. If Peter invests $11,000 at 8.3% interest, how many years would it take for him to double his money? Did it give us our years? No, we're figuring out the years, but it did give us the interest. So all we do is 72 divided by 8.3. All right, and that equals 72 divided by 8.3. It says how many years? You would do 8.67 years. Okay, or you could say, you know, he has to do it at least 9 years. Okay, whatever it asks for it around. Pretty easy, right? All right. So if you have any questions on that, post to the blog. Now you're going to go ahead and do, for the last, I don't know, 10, 15 minutes of class, go ahead and try individually to complete the practice interest and rule of 72 problems. All right. I will record again hopefully tomorrow. See ya.